So this video lesson is all about rational numbers, what it means to be a rational number, and how we order rational numbers, similar to how we order fractions, decimals, integers, etc. And so first we need to look at this word rational, because it describes the type of number that we're talking about. Now, you may have heard rational elsewhere in the English language talking about a thought process that primarily uses logic, or other sorts of arguments, and basically involves using the brain and thinking and logic rather than emotions to make decisions. Well, that's not exactly the kind of rational that we're talking about now. We're talking about a certain type of number, and since numbers can't think or feel or act, this definition of rational doesn't make sense to describe a rational number. But what we do need to look at is that within the word rational, we see ratio. And it's not important at this point to understand what a ratio is to understand what a rational number is. What is helpful is to know that a ratio can be represented as a fraction. And this is only one way that a ratio can be represented, but it can be represented as a fraction. So a ratio of 3 boys to 4 girls. We could write it as 3 to 4, 3 over 4. And this actually turns out to be enough to understand what a rational number is when we look at it this way. Rational contains the word ratio. It's the ratio of one number to another. And so what does that mean? In one sense, we can use colons, we can use slashes, or we can use fraction bars. And a rational number is just one that can be written as a fraction. So, from this definition of rational numbers, it becomes obvious that some examples are necessary to think about what it is, and that fractions themselves are rational numbers. 3/4, like we showed before, is a rational number. 1/2 is a rational number. 19/20, even 19/10, all rational numbers. Now, the important thing about being written as a fraction here is that numerator and denominator both have to be integers. You can't have a rational number determined by 3.5 over 4.7. That would not work. We would have to convert it to something that has integers as the numerator and denominator. And so this breeds the basic question of, are fractions the only rational numbers? And if so, why are we talking about rational numbers in a separate sense rather than just going back and saying, okay, these are fractions, and we use them as we do fractions? Well, anything that can be transformed and represented as a fraction is a rational number. Said a rational number is one that can be written. Doesn't necessarily mean that it's written that way at the moment. So take a second, pause the video, and try to think about what other kinds of numbers can be written as fractions. They may not start as fractions, but what can be written as a fraction? Well, there are two basic other types of numbers that can be written as fractions. One is maybe a little bit less obvious than the other, but let's start off and say decimals. How can we write decimals as a fraction? Well, if you remember back to the converting decimals to fractions video lesson, if we read the decimal, we represent the fraction. That means the same amount of a whole as the decimal does. So if we have 0.42, that is the same because we read that as 42 hundredths. And even though this isn't in simplest form, it shows that 42 hundredths can be written as a fraction. So it is in fact rational. And any decimal that is either repeating or terminating can be written as a fraction. Now, it's important to note here that the other types of decimals, decimals that are non-repeating and non-terminating, of which there's not very many of them, things like the square roots, things like the number pi that's used in geometry. Pi is not a rational because it never repeats, it never terminates, and it can't be written specifically as a fraction. So repeating and terminating decimals are fractions. On the other hand, integers, they can be represented as fractions. You might think to yourself, how in the world can an integer be represented as a fraction? And that's an excellent question. If you want to, go ahead and pause the video and see what you can do to transform an integer into a fraction. Let's say our integer is 7. How can we represent that as a fraction? Well, if we look at 7, we can see that 7 is an integer, and if we had to put it over a denominator, when we looked at multiplying fractions, we can represent any integer as an integer over 1. Now, this also means that it can represent 14 halves, it can be represented as 21 thirds, negative 14 over negative 2. All of these are fractional representations of the integer 7. So in any case, an integer, just by putting it over 1, can be transformed into a fraction. So for decimals, all we have to do to see that any decimal that repeats or terminates is a rational number is just convert it to a fraction. And to see that any integer is a rational number, we just make it into a fraction with a denominator equal to 1, and the integer as the numerator. So let's go ahead and look at the other part of this video lesson, and that's how do we order rational numbers? Now we have several rational numbers here, 6 of them, 3/4, 4/10, 25/100, 7/12, 1, and 0. How can we order these rational numbers? Because it's not entirely obvious where, say, 7/12, where 7/12 fits into this pattern here. We can see obviously that 0 is at one end and 1 is at another. Now we know how to order fractions, we know how to order decimals, we know how to order integers. So using that information, how is it that we can order a mixed set of rational numbers? Taking a step back from this particular example for the moment, in order to convert and order rational numbers, all we have to do is convert all of the rationals either to decimals or fractions. Now it doesn't matter which. In some of these cases, like 3/4 and 7/12, maybe it's easier to convert 3/4 to a decimal. But 7/12 is a repeating decimal. So maybe instead we want to convert 4/10 and 25/100 into fractions and compare them that way. But whatever way you want to convert, you need to convert all of the rationals either to decimals or to fractions, and then you order this new set of numbers. Because as long as the conversion is correct, all of the rational numbers you have will represent the same amount. Now this is particularly important when we're talking about numbers that are not obvious in comparison to each other. For example, 7/12 against 25/100. Perhaps we can see that 7/12 is greater than a half, and 25/100 is less than a half. So therefore, those are easy to compare. But when you throw a bunch of other rational numbers into there, it may not be obvious. But all we need to do is to convert all the rationals either to decimals or fractions, whichever you want, and order the new set of numbers. So go ahead and pause the video and take a look at these 4 problems here and see how you can do that. Number 1, which is the same problem as we had before. Number 2, in the northeast corner. Number 3 in the southwest corner. And number 4 in the southeast corner. So again, converting either to fractions or decimals. It's not important which is which. You can convert to either that you want. But see how you can do with ordering these 4 sets of numbers. And go ahead and restart the video when you're ready to go on. Well, let's take a look at number 1. Knowing that 12ths is going to be a repeating decimal, I would much rather transform my decimals, 4/10 and 25/100, into fractions. So for this one, I'm going to convert them into fractions. 4/10 is the same as 2/5 when you convert it to simplest form. And 25/100 is the same as 1/4 when you convert it to simplest form. Now at this point, you need to transform all of these fractions into a common denominator to compare them. And the common denominator of 4, 5, and 12 is going to be 60. Now without converting them to common denominators here, the answer that you get in terms of the ordering from least to greatest. 0 is the least, followed by 1/4, followed by 2/5, followed by 7/12, followed by 3/4, and 1. Now, if we wanted to convert all of these to decimals, we would have our 1/4 still be 0.25, our 2/5 still be 0.4, our 7/12 we can convert to decimals. We need to convert it as we had done before, where we divide numerator into denominator, so it would be 12 divided into 7. Goes into that 5 times. And we can continue through. That's 60 down to 10. 10 it goes into 8 times. Takes it back down to 40, and then we get a 3 repeating. So 0.583 repeating is what we get for 7/12 if we convert it into a decimal, and then of course 3/4 is 0.75. To look at number 2, if you were going to convert these into anything, the first thing you need to look at is the fact that 15/12 is not in simplest form. And if you looked at this as a repeating decimal and tried to divide 12 into 15, you found that it's actually not repeating. When you divide the 3 away from both numerator and denominator, you get 5/4. This one I'm going to transform into decimals. This is 1.25. 19/10 into decimals is 1.9. And then it becomes obvious what our ordering is because everything is now converted into a decimal. 1 is the smallest, followed by 1.25, 1.375, which is the same as 1 3/8 if you converted that to fractions, followed then by 1.625, which is 5/8 if you converted that into fractions. After 1.65 is 1.9, our 19/10, and finally 2. Now, if we look at 3, 0.4 is a repeating decimal, and we can transform everything into decimals if we want to, or recognize that 0.4 repeating is the same as 4/9. In any case, the ordering that you should have arrived at is 0 as the least. Right after that is 1/3, which is the same as 0.3 with the 3 repeating. After 1/3 is 4/9, 0.4 with a 4 repeating, also known as 4/9. After 4/9 is 0.65, 4/5, and 1. Now finally for number 4, we don't have any integers here to order, just fractions and decimals, and you can convert them in whatever order you want to. I'm going to stick to the decimals because I know the fifths. 11/5 is 2.2. 14/5 is 2.8. And 19/8 is 2 3/8, so 2.375. Which gives us an ordering then of our lowest being 11/5. Next would be 19/8. After 19/8 would be 2.5, 2.5. After 2.5 would be 2.65, 2.8, and finally 2.9. So again, a rational number is just any number that can be written as a fraction. It doesn't necessarily mean that it must be a fraction. Decimals and integers are also rational numbers, but the important thing is they can be written as a fraction, and to order them, we just have to convert all of our rationals either to decimals or fractions if it's not obvious what their value is in comparison to one another, and order the rationals that we get after the conversion.